Okay, a skier is gliding along at 5 meters per second on a horizontal frictionless snow. He suddenly starts down a 15-degree incline and his speed at the bottom is 16 meters per second. What is the length of the incline and how long does it take him to reach the bottom? What we have is a skier gliding along at 5 meters per second and encounters an incline of 15 degrees and reaches a final speed of 16 meters per second. So when the skier was gliding along horizontally, he was only acted upon by the force of gravity, which is right down 90 degrees, which is right down, straight down. But now since he's at an incline, he is acted upon by another vector which is parallel to the incline, and this vector going down of gravity is denoted by g, which is 9.8 meters per second square. This vector is denoted by g sine of theta, and theta is 15 degrees Celsius. Theta is 15 degrees, not 15 degrees Celsius. 15 degrees is angle. So from our formula of final velocity square equals initial velocity square plus 2 times acceleration, but this time acceleration is g sine theta, times the distance. So our initial velocity here was 5 meters per second. Our final velocity is 16 meters per second. Our angle is 15 degrees, and we want to find out the length of the incline. So we know final velocity is 16, initial velocity is 5, and our angle as 15 degrees. Now we need to solve for x. So when we solve for x, we find out the length of the incline. That means the length of this distance right here as 446 meters. Now we are asked to find out how long does it take to reach the bottom. From our other kinematic equations, we know that velocity final equals velocity initial plus acceleration, which is g sine theta again, times change in time. Our final velocity is 16, initial velocity is 5, g sine of 15 times change in time. So we end up with a change in time of 4.3 seconds.